The so-called building blocks of life have been discovered at the coldest and darkest place we have yet to see them because of JWST's unmatched ability to peek into the veiled hearts of distant clouds. The data from the telescope have shown the presence of frozen carbon, hydrogen, oxygen, nitrogen, and sulfur, elements essential to the formation of atmospheres and molecules, such as amino acids, collectively known as CHONS, in a molecular cloud called Chamaeleon I, located over 500 light-years from Earth. According to astronomer Maria Drozdovskaya of the University of Bern in Germany, these elements are important components of primordial compounds, such as simple amino acids, and hence ingredients of life, in a sense. More complex molecules like water, methane, ammonia, carbonyl sulfide, and the organic molecule methanol have also been found in frozen forms by an international team of researchers led by astronomer McClure of Leiden University in the Netherlands. Stars and their planets are created in cold, dense clusters in molecular clouds. The molecular cloud that gave birth to the Sun is thought to have contained CHONS and other molecules, some of which were later transported to Earth by collisions from frozen comets and asteroids. Even while the elements and molecules found in Chamaeleon I are presently floating around in a tranquil manner, they may one day be involved in planet formation and transport the elements required for the advent of life to brand new newborn planets. Astronomer Will Rocha of Leiden Observatory says, "Our discovery of complex organic molecules, including methanol and possibly ethanol, also suggests that the numerous star and planet systems emerging in this particular cloud will inherit molecules in a rather advanced chemical state. This may imply that the occurrence of primordial chemicals in planetary systems is a typical byproduct of star creation rather than a peculiarity of the solar system." One of the nearby active star-forming areas to Earth is Chamaeleon I, a frigid, dense, and black mass of ice and dust. To better understand how these components are absorbed into newly developing worlds, we may gain a better understanding of the components that go into star and planet formation by taking a census of the galaxy's composition. More clearly and precisely than any previous telescope, JWST can see through dense dust thanks to its powerful infrared detection capabilities. This is due to the fact that infrared wavelengths of light don't scatter off dust particles the way shorter wavelengths do, allowing telescopes like JWST to see through dust more effectively than optical telescopes like Hubble. The chemical makeup of the dust in Chamaeleon I is identified by absorption characteristics, according to researchers. Elements and molecules within the cloud can absorb starlight passing across it. Various substances absorb light at various wavelengths. These absorbed wavelengths are darker when a spectrum of the emerging light is gathered. The components present can then be identified by analyzing these absorption lines, according to scientists. For a census of Chamaeleon I's composition, JWST looked deeper than we've ever seen. It discovered ice, colder than any previously recorded in space, at about -263 degrees Celsius, silicate dust grains, the aforementioned CHONS, and other molecules and other materials. Also, they discovered that the amount of CHONS was less than expected for the cloud density, with only around 1% of the anticipated sulfur. This implies that the remaining materials might be trapped somewhere that is impossible to measure, like inside rocks and other minerals. The team wants to gather more information because it's currently tough to estimate without it. More observations will allow them to better understand how these pieces of ice evolved from coating the arid grains of a molecular cloud to becoming part of comets and potentially even seeding planets. It will take several spectral pictures for McClure and his team to fully understand how the ice developed from their initial synthesis to the comet-forming areas of protoplanetary disks. This information will help us determine which ice mixtures and consequently which elements might one day be transported to the surfaces of exoplanets that are similar to Earth, or absorbed into the atmospheres of gigantic gas or ice planets. What do you think? Will these discoveries answer life's toughest questions on the origin of the universe? Or will it give us even more questions instead? Comment your thoughts below. Thank you so much for watching the video. Don't miss out on our latest uploads. If you wish to stay up to date with the latest space updates and discoveries, hit the subscribe button, like the video, and turn on all notifications to see more of our latest videos in the future.